Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS8602, Compiler Design, Unit 5, Topic Optimization of Basic Blocks. We can often obtain a substantial improvement in the running time of code merely by performing local optimization with each basic block by itself. Directed acyclic graph, short from DAG, like the syntax tree for an expression, has leaves corresponding to atomic operands and interior codes corresponding to the operators. The difference is that a node n in a DAG has more than one parent if n represents a common sub-expression in a syntax tree. The tree for the common sub-expression would be replicated as many times as the sub-expression appears in the original expression. As a DAG not only represents expression more sustainably, it gives the compiler important clues regarding the generation of efficient code to evaluate the expressions. Next, we are going to see one example for directed acyclic graph. The DAG for the expression a plus a into b minus c plus b minus c into d by sequence of steps. The leaf for a has two parents because a appears twice in the expression. More interestingly, the two occurrences of the common sub-expression b minus are represented by one node. The node labeled minus, the node has two parents representing its two users in the sub-expression a into b minus c and b minus c into d, even though b and c appear twice in the complete expression. They are nodes that have one parent since both the users are in the common sub-expression b minus c. So the DAG representation of basic blocks, DAG for a basic blocks are as follows. There is a node in DAG for each of the initial values of the variable appearing in the basic block. There is a node n associated with each statement s within the block. The children of n are those nodes corresponding to statements that are the last definitions prior to s of the operands used by s. Node n is labeled by the operator applied at s, and also attached to n is the list of variables for which it is the last definition within the block. Here the certain nodes are designated output nodes. These are the nodes whose variables are live on exit from the block. That there is values may be used later in another block of the flow graph. Calculation of the live variables is a matter for global flow analysis. The DAG representation of each block let us perform several code improving transformation on the code represented by the block. Now we are going to see one example for the constructing DAG from the base block. These are the given instructions. For this instruction, first we are going to start T1 equal to 4 into I. Asterisk is represented as the interior node, 4 and I represents the leaf node. Next we are going to see the T2 equal to A of T1. That means T1 result is stored in the array of T1. Then next one is next statement T3 equal to 4 into I. Then next you draw the diagram for the T4 equal to B of T3. Likewise you have to draw each and every expression. Finally you will get one directed acyclic graph. Thank you.